Dear student, welcome back. We have seen the topic parallel operation of three-phase alternators. In this already we have seen what is the necessity of these parallel operations, and secondly we have seen what are different conditions. We have seen there is a four condition is there. One is a phase sequence. Phase sequence of both the machines should be same. RMS line voltage or terminal voltage should be the same. Phase angle of the two system should be same, and frequency of the two terminal voltage should be the same. Now we are going towards the next topic, load sharing between two alternators in parallel. Because the basic requirement is if the load is more, then we are utilizing more than one alternator to supply such kind of the load. So here you can see a figure shows an alternator, that is the generator 2 is being parallel with a running power system or a generator 1. So in this figure we are going to get connected the alternator 2 in parallel with generator 1. These two machines are about to be synchronized for supplying the load, that is a parallel operations. Generator 2 is to be parallel with the generator 1 by utilizing or by changing the switch S1. This switch should never be closed without satisfying the above conditions. Above conditions means we can say here phase sequence, line voltage, phase angle and frequency. If this is going to get satisfied, then and then we can going to get close the switch here. This switch is going to get closed, otherwise not. To make the terminal voltage equal, this can be done by adjusting the terminal voltage of incoming machines. Incoming machine means this is the incoming machines and this is the running machines. This is the incoming machine, this is the running machines. By changing the field current or make out it equal to the line voltage of a running system using the voltmeters. So when this alternator is going to get connect in parallel with this alternator, so speed control is going to get achieved by changing the excitations. Excitation means a DC current which is given to the rotor of your alternator 2, sorry. So what this will going to get do? Once it will going to get connected in parallel, then the power equations will going to get become like this. So the power generated by the generator 1 plus power generated by the generator 2 is going to get satisfied the load. Here P indicates active power, Q indicates reactive power. So because of the both are coming in parallel, addition of these two is going to get happen. For making these two parallel, we have to go for the phase sequence, the most important thing. Using a synchronoscope, phase sequence can be checked. So we are going to get check the phase sequence, and for that we can say synchronoscope can be going to get utilized. Synchronoscope is a device, it is not actually check the phase sequence, but it is used to measure the difference in the phase angles. So phase 1 R, phase 2 is Y and phase 3 is B. So between three angle our system is the balance when all are displaced by 120. So here we are going to get check the angle. The second method is 3 lamp method. So here in this figure where you are going to get connected the switch S1, this switch is connected by using 3 lamps. The 3 lamps are connected to the terminal of the switch S1. So across each terminal there is a one lamp is connected. So light become bright if the phase difference is large. See here. So I can take, this is the point. You can see here the point. This is the one point. This is another point. So two ends of the light is going to get connected. So this is connected across this. Then we can see this is connected across this. And then you can see this one is connected across this. So it is a 3-phase alternator. So 3 bulbs are going to get connected across each phase. And what we are going to get check? We are going to get check the bulb brightness. If the bulb become bright, phase difference is large. If they will become dim, so this is dim, phase difference is small. The bulb will show dim and bright all together if phase difference is the same. So all the three lamps is going to get show either dim or either bright, but at the same moment. So that time we can going to get say phase sequence is the same. The bulb will get bright in progression if the phase sequence is opposite. Means the phase sequence is RYB, and here if we are get RBY, then we can say it is a get bright in progressions. This phase sequence can be made equal by sweeping the connection of any two phases. Means previously here the phase sequence is R, Y and B. In progressions you can see the phase sequence is Y, B, R, B, Y. So what we are going to get do? We are going to get interchange the two connections and making it R, Y and B. So it will going to get changed. The third point which is coming out, we have to check and verify the incoming and running system frequency. So frequency of this machine and frequency of these machines. So frequency F1 and F2 we have to check. It should be nearly the same. This can be done by respecting the frequency of dimming and brightening of the lamp. Concept is clear? When the frequencies are nearly equal, the two voltages, incoming alternator voltage and running system voltage, will alter the phase gradually. These changes can be converted and switch N1 can be made closed when phase sequence or phase angle is equal. Concept is clear? So here we are going to get say we are going to get change the phase sequence. The 4 point is there. First is related with synchronoscope, another is related with 3 lamp load. So this is going to get utilized. Another is going to get say incoming and outgoing incoming and running system frequency is going to get checked, and then the phase angle. So phase angle, frequency, voltages and phase sequence. All the 4 conditions are going to get satisfied. So what we are going to get say here, why we are going to get this? So there are few advantages is there. The advantages of parallel operating alternators. When there is a maintenance or an inspections in your plant, that time one machine can be taken away from the group of the machines for service, and the other alternators are kept running continuously to supply the load or give the supply. Load supply can be increased. So depending on your requirement, you can add or delete the number of alternator. During light loads, more than one alternator can shut down, while other will be operated near to its full load. Then because of all these, the efficiency is going to get increased. So efficiency will become high. Because of this, all the alternators or the number of alternators which are running near the full load or rated load, so we can say operating cost is reduced. It will ensure the protection of supply, that is continuous supply, and enable cost effective generations. Generation cost will reduce. Breakdown of generator does not cause any interrupt to the supply, and the reliability of whole power system is going to get increased. Already just a few days before in the lockdown, you have seen when our Prime Minister Modi has said that we have to on off the load, so lighting load should going to get off. So there are lot of discussion is going to get takes place on whether frequency is remaining stable or grid stability is there or not. So this is the same condition because there are n number of operating generating stations are there. In each generating station there are some sets are there and all sets are running in parallel. When these sets are running in parallel, that time according to the load we are going to get adjusted the alternators. And if lighting load, or you can say because of the domestic load, suddenly the load is going to get reduced, it will going to get hamper the speed of the alternator because load is going to get reduced. That is called a drastic change in the load. If this load is going to get changed, means speed is going to get changed, so it will going to get affect the frequency, which we have seen last video. So because of that, all the power engineers are in worry, and no doubt because of the active participation of all the electrical engineers, especially the power engineers which are working in generating stations, we are in a position to maintain the frequency within a tolerable limit. Thank you.